So, one of the main problems that we have when we look into the night sky to observe things going on in space is light pollution. Light pollution is obviously different than regular pollution. There can be some overlap, actually, believe it or not, but essentially, too much light makes it so that we can't see what's going on. This is a view right here that you would never normally be able to see because all of these lights would obscure what's going on up there. So if you actually look around the globe, you could see that there's certain places that are lit up at night. We are a society that is very plugged in. We have a lot of electricity going on. So any area over here that you see there's a lot of lights there, it just makes it so it's like much more difficult to see the night sky. But in more rural areas, you get a totally different view of the night sky that you wouldn't normally be able to see. So you could see in this example here the before and then the after, just turn off the lights and then letting the exposure come through, you're able to see more, including that band of light there that's showing off the middle of the Milky Way galaxy there. And then I think this is pretty interesting. If you look over here, if you're in like New York City at night, you might only see a couple of stars sticking out. But if you're in like over here, totally rural area, you really get it's a treat at night to be able to see all the different things that are not normally visible. I would say we're kind of more in this region over here between 7 and 5 over here where what we're able to see. So you can see stars at night, but there's a lot of people nearby, and that means a lot of lights on at night that is stopping us from being able to see what's out there. So I would like for you to write this down. Where are we in space? We are located in the solar system. We already talked about how the universe is the largest thing, and then a galaxy is smaller than that. We live in the Milky Way galaxy, and there are hundreds of billions of stars in there. We're just one of them. So our sun, right over here, is this is the solar system. It's a system, multiple things working together. It's composed of the sun. The sun is a star, and all of the planets and all the other celestial bodies that travel around the sun. So I want you to think about for a second. What do you think this term means? Celestial bodies. These are objects that are out in space. So what are some other examples of celestial bodies other than the planets? Probably thinking for a second. The answer would, of course, be things like dwarf planets and moons and other space rocks that are out there as well. Now, the solar system is drawn together by gravity. The source of gravity, please write this term down as well. The source of gravity in our solar system is the sun right there. All of these objects are orbiting around that. And it's actually very likely that every single star that we see in the night sky is most likely its own solar system, meaning it has its own system of planets going around it. Does it mean that all of them have eight? No, definitely not. And the order of the types of planets might be different in some of these star systems. The gas giants over here, which are located in the back half, right? The closer ones tend to be the smaller ones, and then the further away are the gas giants. But it's we've seen that a lot of times the Jupiter-like planets are actually a lot closer. They call them hot Jupiters. So, our solar system may be unique. It may be quite common, but all we know is, of course, that this is our layout right over here. If you notice that the Earth to scale, right, about a million Earths can fit inside of the sun over there. So the sun is much, much larger. You see another perspective over here, how tiny all of the planets are comparatively to the sun. The sun contains, I believe it's 99% of all mass in the solar system is located within the sun right there, which is pretty crazy. And this is another interesting thing. Pop quiz for a second. What color is the sun? Think about it for a second. Make your prediction. What do you think the answer is? The answer is that it depends. It depends on what time of day you're looking at it and where you are. So, if you were to look over here, if you were to say it is orangish white, okay, yeah, yellowish, that could work. Over here, it seems like a dark yellow with maybe some red. That's also correct. Notice that the further down it goes, you get more of that reddish tint to it. Now, if you look over here, these are two other images of the sun as well. And this is also accurate right over here. The only difference is that it's not here on planet Earth. So this is an image of the sun, but it's from a camera out in space looking at the sun. And you'll see it's a little bit more bluish, and it's definitely a lot more white, like pure white over here. This image over here is another sunset, but it's on the planet Mars. So this is a Martian sunset over here. And you'll notice that it doesn't come through as red. So a lot of that has to do with the fact that our atmosphere is so full of gases. And then as the sun's light comes through, it gets scattered through all the stuff that's blocking it. And of course, on Mars, they have a much thinner atmosphere there, so it doesn't do the same effect there. And that's why it looks like it's more pure color, which a lot of people would argue the real answer to this is that the sun is white. So it really just depends on your perspective. So again, our phenomenon here, why does the sun look different on space or on Mars? I'll give you a chance to think about it. Kind of just gave you the answer. But of course, the reason is that our atmosphere that we have here scatters the light. Our atmosphere actually blocks a lot of other stuff that we can't see. Out of the entire visible spectrum over here, um, we only see the visible light. We don't see infrared, that's like beyond red. We don't see ultraviolet, that's like beyond violet. We just see what's in here. And a lot of this other stuff, some of these rays are quite harmful to humans, get scattered and blocked by our atmosphere, which is really good. So if we look over here, we're going to look at some other different types of stars. So this is Rigel over here, and this is Betelgeuse, sometimes pronounced as Betelgeuse, depending on how you want to pronounce it over here. And you notice that this star is more shifted towards the blue, and this is more shifted towards the red over here. If you look over here, you can see a size comparison, how much larger the red giant of Betelgeuse is compared to some of the other ones. Here's Aldebaran, which sounds like a star or planet out of Star Wars or something. There's Rigel, comparatively a lot smaller, and then it keeps getting smaller and smaller. And look how tiny our sun is compared to these two over there. Now look how tiny our sun is. Can't even really see it right there. It's just one little pixel compared to one of the largest stars ever discovered, which is VY Canis Majoris. One of the reasons I like to bring this up is if you look in the night sky, you can sometimes see constellations. There's really nothing so special about constellations. It's just like patterns that our ancestors looked at and they thought looked like patterns. All of these stars may be really far away from each other, but from our perspective right here, they form an interesting shape. So Betelgeuse over here is part of it. And then Rigel is the one on the bottom. Rigel is like one of the top five probably brightest stars in the sky, and Orion's belt are clustered together right there in the middle there. So this is probably one of the easiest ones to spot with the naked eye. Betelgeuse is one of those large stars that is expected to go supernova at some point in the near future. So I mentioned before, visible light, all we can see is this. This is just what our bodies are able to comprehend, our eyes are able to comprehend. But through the methods and tools of science, we are able to actually detect all of these other types of rays that are emanating from it there. So when you look at the sun, you can see, okay, we might be able to see just one portion of this over here. Excuse the train in the background. But you can see through different lenses all the different other types of rays that are coming through, and it'll look different. So really it's all just a matter of your own perspective, right? Speaking of which, this is an image that was taken at Sharp Reservation a couple years ago. It was a really, really special night, and it's called the Northern Lights. So what happens is that supercharged particles that are coming in through our atmosphere get scattered right over here. So during a time where the sun is especially active, it sends out these particles, and again, it gets scattered to the wind, and depending on what type of material is coming out of the sun at that time, it gives waves to different colors. So we got these beautiful reddish, pinkish, and some green hues that are coming in through over here, and that was just a really special treat. The Northern Lights are quite a rare thing to see, so we were all really lucky that we were able to see it there. So far south in the equator. I'm sorry, not the equator. So far south of in the latitudes. Normally, you'd have to go much higher up, and only certain areas around the world would you be able to see it. So that was a really cool special treat. Here's a couple more images I was able to take. Fun fact, it looks a lot better on camera than it did in person. Still a very cool experience, but it just the light comes through so much more when you have extra time to look through it. Now, I'm going to, I would like for you to maybe pause and read through this because this is an awesome poem. It's, a classic play on Twinkle Twinkle Little Star, but instead of saying, oh, I don't know what it is, we know exactly what it is. So as you look through, these are the two questions I want you to answer. What's the most common color of star? And then how old will our star be when it dies? No, technically, is our star really alive? No, but it does have a sort of a life cycle to it. So let's see if you can figure it out. Pause. And we're back. So the answer, what is the most common color of star? The answer here is that it is red. It says red stars dominate by far. Now, how old will our star be when it dies? The answer should be roughly about 10 billion years old because it says formed 5 billion years ago and it's halfway through its life so far. So that's roughly what happens to most stars as it goes through. So here is the life cycle of a star. It starts off as a stellar nebula, just a collection of gas. And if most of the time it just forms into an average star like ours, it will eventually go into this red giant phase, which will then sort of dissipate and then just be left over as a white dwarf, just a small remnant of what it once was, not nearly as strong as it was before. So, in terms of the life cycle of the sun, we're smack dab in the middle of our life cycle over here. It will eventually reach the red giant phase. It's projected in about 4.5 to 5 billion years, and then it will dissipate into the white dwarf status after that. Now, only the most massive of the stars over here become a red supergiant, like Betelgeuse did, the one we talked about earlier. When that reaches the end of its cycle, it will supernova, which is a gigantic explosion that sends out matter in multiple ways, and will either result in a neutron star, it's kind of like a white dwarf, but very, very, very small, very, very densely packed in together, or the dreaded black hole.